Producing efficient cattle with a light environmental footprint is the goal of an innovative trial being held on a North Canterbury farm. Geneticists from Beef and Lamb New Zealand's Informing New Zealand Beef program, scientists from AgResearch and Tamania Angus Stud are working together on the project.
New Zealand, unlike other countries, a substantial proportion of our emissions come from agriculture. A large chunk of that comes from what we call enteric methane, which is basically animals, ruminants, breathing out methane. And so if we can make some reductions in that, then that is going to contribute towards New Zealand's national greenhouse gas position. And that's really important from a national and societal point of view, that we have a go at doing our bit.
At the moment we are tasked as an agricultural industry with lowering our emissions by between 24 and 47% by 2050. So in order to do that, we need to start lowering emissions on farm by just around 1% per year.
The animals we've got in here are part of our progeny test, so they're Hereford and Angus and crosses both ways of Hereford and Angus. There's a bin here which is full of a silage-based feed, and that bin is on load scales. And so the animal comes in, we know which animal's there because an antenna reads its electronic tag in its ear. The animal eats, the bin gets a bit lighter, so when the animal leaves, we know how much it's eaten by how much of that bin's weight is reduced by. And we need to have them in here for around about 50 days to get a good estimate of both their feed intake, but actually just as importantly their weight gain over that period. We want to understand how much these animals are eating, how productive they are and how fast they're growing, but also along with that how much methane they're emitting. And between the three of these things we want to get animals which are feed efficient, so produce a good amount, eat less and emit less methane.
We first set up these portable chambers in sheep and we've exported them to 7 different countries, and we have an international collaboration.
We've upscaled these for cattle and we're having a crack at this with beef cattle, and we're talking with our equivalents around the world in terms of how we collaborate and make it a joint effort in cattle.
There's a lot of work going on in Australia measuring cattle for methane, but we want to kind of ramp that up with something more practical on farm. And I see those packed chamber measurements as something that can be lower cost and can be done on farms like this stud operation here at Tamania.
This is a first for cattle. So we actually built these ourselves a couple of years ago using AgResearch engineers. All we're trying to do is hold an animal in one place for about an hour and measure how much gas or how much methane gas is emitted from the animal. And then we use that 1 hour measure to work out how much per day that animal is emitting. So we're looking for the animals that naturally emit less methane than their contemporaries. We're working alongside Beef and Lamb because what we really want to do is use this information in line with all of the other data that we're collecting on animals so that we have a genetic profile so that we can rank animals for breeding.
So the idea is to find those outlier animals that do the best job of this and to breed from them essentially, so that we make our cattle progressively, each generation they become better and better and better.
We've had some animals eating 30% less than the average and growing the same amount as the average, and some animals eating 30% more than the average and growing the same amount. So there's big variation. For me that's exciting. If we've got variation we can make selections.
A lot of questions come up about how are the cattle going to go in the packs, you know, how they're going to go in, how they're going to come out, what's the environment like for them in there. And it was basically today it was exactly kind of how it was described to us. They're just super calm.
They're quite used to being weighed in a similar sort of environment. They walk in really nicely. We have the boxes just slightly uphill, so it's a nice comfortable walk in for them. And then we shut the doors, and what we find is actually they quite like the dark. So they really like a calm, dark, quiet space, and they're only in there for 45 to 50 minutes. And we find that they're really untroubled by it.
If we use genomics and we genomically test the animals that we're measuring here, then we can infer or predict what other animals will do just based on a sample of tissue taken just after birth, any time really. And so we can then say, well, these animals are likely to be more feed efficient and more methane efficient as well. The way to utilise this on farm is essentially to go and buy a bull with good figures for the stud herds that are involved. They will then find better bulls to use themselves, and so all the bulls that they're selling over time will lift, and then those bulls will go out and work on New Zealand commercial farms and lift our national performance of our national herd.
We do see this as a global issue, that we can't just be doing it individually, that this is really one of those collaborative ones where we're all striving for the same thing, you know, improving the sustainability of the farms, but also making sure that we're going to have market access in the future as well.
If we don't measure it, we won't know. And then it becomes indefensible. So we can now say we have measured our stock on farm, we understand the impact that they're having, we know how much methane they're emitting, and we can show what we're doing about it.